Welcome students, we are asked to integrate integral dx over x squared negative 1. Now this is a direct formula. There is a direct formula involving this. But whenever they are asking this question, they will ask you to show the result of this question. So more so it will be required that you will have to work out the entire thing. You can't be allowed to use the formula unless or until if you are finding this as part of another big question. So I will show this to you how exactly you can achieve the entire working for this question. So foremost, let me just consider x squared negative 1. I'm going to rewrite this as x squared negative 1 squared. Now this is similar to a squared negative b squared, which is rewritten as a negative b positive, or I should say a negative b times a positive b. So this is going to be x negative 1 times x positive 1. So therefore integral dx over x squared negative 1 is rewritten as dx over x negative 1 times x positive 1. Now we have to use partial fractions to split this. So consider x negative 1 times x positive 1. I'm going to rewrite this as a over x negative 1 positive b over x positive 1. You cross multiply, and you cross multiply, we get 1 is equal to a times x positive 1 positive b times x negative 1. Now choose values for x for which one of the terms vanishes. Now let me take x is equal to negative 1. If I were to substitute the value of x is equal to negative 1 over here, this term will vanish, giving me 1 is equal to b of negative 1, which is equal to negative 2 times b. Therefore, you have got the value of b to be as negative 1 over 2. Now choose the value of x such that this term vanishes. So I take x is equal to 1. If I were to do that, this will vanish, giving me a of 1 positive 1, which is equal to 2 times a. On the left you got 1. So a is equal to 1 over 2. So now you got the value of a, you got the value of b. You take this to be as 1. So therefore I can rewrite now 1 over x negative 1 times x positive 1 to be equal to 1 over 2 divided by x negative 1. That's the value of a. Positive negative 1 over 2 divided by x positive 1. That's the value of b. So therefore, when we are asked to integrate integral dx over x negative 1 times x positive 1, we can now rewrite in place of this quantity 1 over x negative 1 times x positive 1, this quantity 1 over 2 over x negative 1 positive negative 1 over 2 over x positive 1. Of course, you got to have the dx operator. Now I can further rewrite this as 1 over 2 integral dx over x negative 1 negative 1 over 2 integral dx over x positive 1. This is further rewritten as 1 over 2 integral of dx over x. That's going to be, this is actually integral dx over x negative 1. That's going to be ln of x negative 1. You need to place the modulus sign. Followed by negative 1 over 2. This is going to be ln of x positive 1. Now I can remove the modulus. Why I can remove the modulus? Because x is going to be positive, right? Now you may be wondering, how do I know x is positive? I am considering x to be positive because it's indefinite integral and limits are not given. So therefore I'm going to take this as ln of x negative 1 followed by negative 1 over 2 ln of x positive 1. Now I'm going to take 1 over 2 out and rewrite this as ln of x negative 1 negative ln of x positive 1. Fair enough, right? Close the parenthesis. Now I'm going to utilize this part of the page. Now ln of a negative ln of b is rewritten as ln of a over b. So I would like to utilize that formula. So this is equal to 1 over 2 times ln of x negative 1 divided by x positive 1, positive arbitrary constancy. So this is the outcome. This is the value that I have got. So therefore integral dx over x squared negative 1 is equal to 1 over 2 times ln of x negative 1 divided by x positive 1, positive arbitrary constancy, Now this is the final solution for this question. Now, having mentioned that, now this question can be manipulated in many ways if they want to ask, right? So because the value of the constant that you see here is 1. It can be 2, it can be 3, it can be 4, it can be root of some type of constant. In any case, this is a constant, have it in mind, and this is a variable. Every time the constant changes, the formula will change. Having mentioned that, you have to be a little bit cautious when applying or when you come across this particular question. So thank you, students, until we meet again in the next problem.